In the real estate consulting firm, our task is to develop a regression model that predicts housing prices and advises property investors on key value drivers. Using the Boston housing dataset containing 506 observations across 14 features including property characteristics, location factors, and neighborhood quality indicators, we developed a multiple linear regression model to predict median housing values. Our objectives are to identify which features significantly influence prices, evaluate model performance using statistical metrics, and provide actionable investments, recommendation on which factors prospective buyers should prioritize when purchasing properties. Housing price prediction is a fundamental application of regression analysis in real estate industry. As data analyst for a real estate consulting firm, understanding the complex interplay of factors that influence property values is essential for advising clients on strategic property investments. Accurate price prediction models enable investors to make informed decisions, access market trends, and identify properties with strong investment potential. This case study addresses the challenges of predicting house prices in a metropolitan area by developing and evaluating a regression model based on various property and neighborhood characteristics. The analysis utilized the Boston housing dataset, which contains comprehensive information about housing attributes and socioeconomic factors across different neighborhoods in Boston, Massachusetts. Objectives for our model is to identify and analyze the key features that significantly influence housing prices in the Boston area, to develop a multiple linear regression model that can predict median housing values with reasonable accuracy, to evaluate the model's performance using appropriate statistical metrics, to provide interpretable insights into how each feature affects property valuation, and to assess the practical applicability and limitation of the predictive model in real-world scenarios. In this project, we use Orange data mining software to analyze property values. The methodology involves feature standardization, splitting the data into 70% training and 30% testing, and applying a multiple linear regression model. We evaluated performance using R-square, MAE, and RMSE with the key advantage being interpretability. We can clearly see how each feature impacts housing prices. The significance of this analysis is broad. Investors can identify which factors drive property values, real estate agents can make data-driven pricing recommendations, urban planners can recognize what enhance property values, and policymakers can better understand how socioeconomic conditions affect affordability. Overall, the impact is transparent, accessible, and actionable insight that supports smarter decision-making. Now, let's look at our problem statement. The primary challenge addressed in this study is to develop a predictive model that can accurately estimate median housing prices based on multiple housing and neighborhood characteristics. Real estate markets are complex, with prices influenced by numerous interrelated factors, including crime rates, property attributes, environmental conditions, and accessibility to amenities. Understanding which features have the strongest impact on housing prices and quantifying this relationship is essential for effective price prediction.
Hi, my name is MAISARAH and I'll be talking about data analysis and feature selection. First, for feature selection, there are 14 variables that could be chosen from. There are median price of owned and lived-in home, crime rate per capita by town, percentage of land for residential use, percentage of land for non-retail business, if the home is close to the Charles River, the measurement of nitric oxide concentration per 10 million in the air, average number of rooms, age of the housing, distance to 5 Boston employment centers, how well connected a neighborhood is to the highway, the tax rate, the educational quality by measuring pupil and teacher ratio, percentage of population that identifies as black, and percentage of lower status population. From the 14 features available, we had chosen the feature MADV. MADV represents median price of owned and lived-in homes. We choose the feature because it directly reflects the price of home, which is the primary interest in real estate analysis. This feature also serves as an economic indicator, especially since it will not be affected by estimate values. Next, I will be talking about data analysis. The first one is data preparation. The dataset that we had obtained does not require cleaning. However, we did perform pre-process. In the pre-process widget, we had chosen the normalized features and the option standardized to average equal to 0 and standard deviation equal to 1. Standardizing aligns the variances that are present in the dataset to avoid any variables to dominate. This will lead to a more accurate model and easy result to interpret since it is adjoined better during training. Other than that, we also did data sampling using data sampler widget in Orange. It is important in evaluating model performance both on the data it was trained for and on new data. For this dataset, we set the proportion for the training set to 70% and 30% for the testing dataset. This will allow a sufficient amount of data to train the model while still accurately represent overall population. The option replicable deterministic sampling was also enabled so that the same subset of data could be reproduced when needed, thus maintaining the reliability and validity of the result.
Assalamualaikum warahmatullahi wabarakatuh. My name is HAZWANI NURIN ATHILAH BINTI ZAINAL. For this session, the selected model is multiple linear regression. This model was chosen because the main objective of the analysis is to predict the median house value, known as MEDV, which is a continuous numerical variable. Multiple linear regression is suitable for modeling relationships between multiple independent variables and a single continuous target variable. This model was also selected due to its high level of interpretability. In the context of real estate analysis, it is important not only to predict house prices, but also to understand which factors influence those prices and in what direction. Linear regression provides clear coefficient values that show how each feature, such as crime rate, number of rooms, or socioeconomic status, contributes to changes in housing prices. Before model development, the dataset was standardized during the pre-processing stage to ensure all features were on the same scale. This step helps prevent bias towards variables with larger numerical ranges and supports more stable and reliable model results. In terms of model configuration, the fit-intercept option was enabled to allow the model to calculate a realistic baseline housing price instead of forcing the regression line to start at zero. This setting is more appropriate for real-world property data. In addition, regularization was not applied so that the original feature weights could be preserved and remain easy to interpret. Overall, multiple linear regression provides a simple, transparent, and effective modeling approach that aligns well with the objective of supporting real estate decision-making.
Hi and Assalamualaikum, I'm IFFAH, and in this video I'll be presenting about model development and evaluation. This predictive model is developed in Orange data mining using systemic approach to ensure data integrity and model robustness. The first step is data integration, where the dataset is loaded using the file widget followed by pre-processed widget to standardize features in order to prevent scale bias by the algorithm. Next, we split the dataset into 70-30 ratio, where 70% of it is used for training while the rest is used for testing. Lastly, we choose multiple linear regression as it can handle multiple independent variables to create a single continuous prediction that is the housing price. To summarize this model, we need to look at the set of coefficients produced by this model training, where we can get the overall regression equation. We can see the overall regression equation above. Variables are categorized based on their impact on the model's logic. First are the primary value drivers, which are features with positive coefficients that increase the property's market value. Next are the primary value subtractors, which are features with negative coefficients that decrease the property's market value. Lastly, the environmental and safety factors, where features about these factors with negative values will result in discounted price for properties in that area. For evaluation and performance metrics, we take R² and root mean square error into account. R² score displays the proportion of variance in housing prices that is predictable from the selected features. A high R² value provides a strong explanation for price fluctuation, as the closer its value to 1, the closer it is to a perfect prediction. Features with high coefficient values are responsible for a large proportion of this score. Root mean square error measures the average magnitude of the prediction error, as it provides a real-world estimation of how many predictions deviate from actual market values. The model's RMSE score of 4.714 shows that on average, its predictions are off by about $4,714 away from actual property price. This metric squares the error before averaging them, which means it penalizes big errors more than small errors. From this evaluation, we can confirm that this model is suitable to be used as a tool in predicting housing prices for real estate consultancy, as it is verified through 30% dataset testing that this model is good at generalizing and does not simply memorize the training set. This shows that accuracy in prediction is ensured for future investment recommendations. Lastly, LSTAT and RM has strong coefficient values that suggest these two features are the most crucial factors when advising clients on property valuation. That's all from me. Thank you.
Let's look at what actually drives property value in this metropolitan area based on our regression coefficients. Socioeconomic factors, LSTAT. The most powerful predictor we found was neighborhood socioeconomics. Especially, a high percentage of lower status population shows a strong negative impact of negative 4.07, indicating that location demographics are the primary driver of lower valuation. Physical attributes, RM. On the positive side, the average number of rooms is a key value driver with a coefficient of 2.30. Especially, more rooms consistently translate to higher market prices. Infrastructure, RAD. Interestingly, accessible to radial highways also significantly boost value at positive 3.18, showing that connectivity is a major priority for buyers. Proximity and safety. Finally, distance to employment centers and crime rates both act as deterrents. As distance from jobs increase or crime rates rise, property values drop noticeably, with coefficient of negative 3.32 and negative 0.97 respectively. While our model is statistically strong, it has 4 critical limitations we must keep in mind. Non-linearity. First, real estate doesn't always work in a straight line. For instance, the edge of a house often follows a U-shape, where very old and very new houses are both expensive. Our linear model misses that nuance. The human element. Second, the model is blind to soft factors like high-end kitchen renovations or the popularity of a local park, which can cause prices to deviate from our mathematical estimate. Outlier impact. As you can see in the red sections of the chart, extreme cases like very high crimes or high tax areas can skew our results, making the model less reliable for the average house. Final verdict, because of this, we view this model as a GPS for valuation. It gives us the right direction, but a human expert still needs to be in the driver's seat to make the final investment call.
In conclusion, our model achieved R² of 0.725, which explains 72.5% variance in Boston, with average prediction errors of $3,359 to $4,714, demonstrating strong predictive capabilities. The top 5 price drivers is socioeconomic status, distance to employment, highway accessibility, number of rooms, and lastly, crime rate. Our model transparency enables investors to understand precisely which factors drive property values.